company that we have?
The next company that we have is T2 Alloys Limited, which is not only the speaker but also the honorable sponsor of our event.
Indeed.
And for the presentation, we are going to United States of America. So T2 Alloys is the global provider of Tungum tube alloy for pneumatic and hydraulic applications. Tungum alloy was first produced in 1930s in the UK and has since been used for several applications across many industries, including offshore and marine. The main benefit in using Tungum over traditional stainless steel alloys is Tungum can be used in seawater applications and not suffer from crew ice or pitting corrosion. More about this we will hear directly from the speaker, which is Ruben Muro, the global sales person is responsible for the global sales in T2 Alloys Limited. So okay, we are really looking forward for Ruben to join, and we see that our speaker currently is joining the forum.
And we already have him. Hello, Mr. Ruben.
Hi, how are you?
We're great, thank you very much. How are you?
I'm good, thank you. Thanks for asking. It's very early here in Houston, Texas, but nice and sunny, and yeah, it's nice. How are you guys?
We're doing just great.
Yeah, and the weather is nice here too.
The weather is nice here too. And regarding, you said you're in Houston, Texas. It's USA. Do you have any accounts in Europe?
We actually are based in Europe, where the UK specifically. So our main facility is located in the UK, and we have distributors all around the world. It just so happens that I live in Houston, and this is where I do my work from. Previous to COVID, there was a lot of travel involved, and now it's reverted to the interchange that you and I have now going on, which is all video conference. But no, we do have locations all over the world.
Okay, fingers crossed we will be able to see each other again in physical contact, physical conferences.
I hope so, I do.
Yeah. Okay, Ruben, so what's left actually is for us to ask you to share your screen, what you are doing right now, and yeah, we can see you on the full screen, we can hear you.
So you're all well prepared.
Yeah.
Excellent. And again, thank you for the introduction. Great job describing what T2 is and what Tungum offers to the marine industry. It's very important to get the message out. The material has been in existence for many years, as you mentioned, and it just so happens that people just don't understand what it does and what it can do.
Let's make them understand.
Yeah. So just a very quick introduction into Tungum. I assume you could see my screen, correct?
Yeah.
Yes, we can see
everything's perfect.
Excellent. So brief introduction of Tungum. We'll look at some of the common issues on why Tungum is typically used. We'll look at the benefits, the applications, of course, the cost, installation examples, and specifications and approvals. And keep in mind, as you mentioned in some of the previous presentations, this is going to be a very condensed presentation on Tungum. There are many more technical aspects to the alloy that need to be discussed, and certainly before application. So please know that there is more information to follow, and we are always available for follow-up if necessary. So a brief introduction to Tungum. Tungum is a copper-based alloy. If you look at the alloying elements, it actually has 80%, 82% copper, with the remaining balance in aluminum, nickel, silicon, and zinc. The main constituents being copper and zinc make this a brass alloy. It is an alpha brass alloy for those who want to get very specific and very technical. But this is one of the important aspects of the material because it is copper. And people in the maritime industry know that copper does very well in seawater applications. The other advantages and benefits of Tungum is what we will cover. Before we do that, let's look at the issues that the maritime industry faces. The problem is corrosion. Corrosion is inevitable. It's going to happen, and specifically with respect to tubing, it's pitting and crevice corrosion, which are the main factors that cause the failures on equipment on any maritime vessel. Platforms, ships, container ships, cruise ships, yachts, whatever the case may be. The main issue is that pitting, number one, pitting is very hard to detect because it doesn't show up until there's an actual failure, an actual breach in the tube. Crevice corrosion, because it's hidden under a crevice, hence the name, is even more difficult because you don't see that until you have a failure as well. These are the main problems, and the main problems always attack iron-based alloys quicker than they do copper-based alloys. The typical alloys that we see are 316, 317, even 6 moly and super duplex alloys, which are a little bit more advanced and complex and actually higher in cost. But though these corrosion issues still attack these iron-based alloys. So the solution is tungum. Tungum, being again a copper-based alloy, is very well suited for corrosion resistance in seawater applications, and ultimately does very well. One of the main benefits, of course, is the corrosion. The other benefit is that because of the combination of alloying elements as well as the process involved making the product, increase the strength of the material. So according to ASME and ASTM calculations and allowable stresses, the strength of the material is almost exactly the same compared to 316 and 317. What this means to the end user is that this brass alloy, this copper-based brass material, can be used in the exact same pressures as compared to the traditional stainless steel alloys. This is a massive benefit because it's always been thought that the brass alloys and the copper-based alloys are weaker and not as strong as the iron-based alloys, and therefore not used for certain applications because of pressure. Well, now with Tungum, you have that added benefit. You have both pressure rating as well as corrosion resistance, which means that you have a perfect solution for long life, long lasting applications. And again, when you're building a vessel, maritime vessel, these users know that they want to build a vessel and they want to have something in place for more than 2 years, 10 years, 15 years. You're looking at building a vessel and having this vessel last at least 30 years in operation without any issues. Tungum helps you do this. So just as an example on the failures that have been experienced in the past, this is a typical crevice corrosion failure that you see. You could see my pointer circling the crevice area, and of course blotchiness of corrosion all along, in this particular case, 316 stainless steel. This very specific crevice was formed by the clamping that was used to actually hold the material in place. This is an offshore vessel. This actually came from North Sea area. And at the time that the user found this, they started looking for alternatives and they found Tungum. And what we found was a perfect solution to this very specific crevice problem. They put material in place, and as it so happens, about 10 years later, they went to look at the material, and what they found was the Tungum was still in place, no leaks, but it did discolor. This is known in pretty much all copper-based type alloys, where you change colors from a very beautiful gold copper-like luster. The material itself forms an oxide layer, and it morphs into a brown and eventually the verdigris green color that you see on architectural design of copper. Perfect example would be the Statue of Liberty, the Eiffel Tower in some sections. Ultimately, that green look is what you will see eventually. The important part for the user to understand is that that particular film, and the film that you see here in brown, that is an oxide layer of Tungum that has formed. Over time, that oxide layer forms upon itself and morphs into these various colors. The oxide layer never penetrates into the base material. And that's important to understand, because what that means to the end user is that although the surface is changing colors, the material remains intact 100%. The wall thickness is still there to support the pressures, and therefore there are no issues with respect to leaks. The key benefits, and this is important to understand, no failures when used correctly, installation as well as application. This means that one of the biggest benefits are excellent lifetime costs for the overall project. If you're building an asset worth a couple of $1 billion and ultimately you need the tubing installed on that vessel, this is a perfect time to install something that's going to last 30 years plus, and you never have to change it. It is a true fit and forget material to help you with repairs, downtimes. All these things are some of the benefits. Many years of experience, so we have not only the science behind the application, but we also have real-time applications where we can prove zero failures over the course of the asset's life. Because it is a copper alloy, the ductility is slightly less compared to iron-based alloys. This means that the installation is going to be quicker compared to stainless steels. Remember, there are two factors with respect to strength and ductility of the material. So one is the yield strength and one is the ultimate tensile strength. The ultimate tensile strength is what's used with respect to calculations of all the pressures via ASME and ASTM. This is what's similar to stainless steels. The thing that is a benefit is that the ductility, the yield strength is slightly less, which means it's easier to install, easier to bend, easier to manipulate. This accounts for the ease in installation compared to some of the other iron-based alloys. The other benefit is that connections, you can use a typical 316 stainless steel fitting. This is what many people ask the question. I can't use a 316 tube, but I can use a 316 fitting. Yes, that is correct. And the reason being is that if you look at the galvanic compatibility between 316 and Tungum, they're almost identical. In fact, Tungum is slightly anodic, which means that the overall larger surface area of Tungum is actually protecting that very small connection between the 316 fitting and Tungum. Therefore, the reaction never takes place, and the fitting is somewhat protected by the tubing itself. Again, this is proven not only scientifically by tests that we have done in the lab, but also with applications that we have seen offshore in many applications, military vessels, commercial vessels, oil and gas vessels. And ultimately, we have that experience as well as the testing knowledge to prove that you can use a 316 fitting. Now, if the 316 fitting is not to your liking and you want a like material, a typical brass fitting, although the mechanical strength is slightly less compared to Tungum, can be used. And the reason being is because the fitting itself is so large in thickness compared to the wall thickness of the tube. Typically, the mechanical properties are insignificant, and therefore it will hold the pressures that the tubing can hold. Typical fittings would be a 37-degree flare fitting, the J-type fitting, which is typically used in industry. So you can use common fittings using Tungum, again, further reducing the cost of the overall system. Now, the type of applications that you will see in typical maritime applications are going to be mainly hydraulic, which include lifeboats, winches, hatch covers, cargo doors, all kinds of different applications where hydraulics are used, steering systems, et cetera, et cetera. With respect to other applications, fuel lines, potable water, and any type of gas with respect to nitrogen, oxygen, and compressed air for air systems, depending on the vessel and depending on the application. And again, Tungum being specified for superior corrosion resistance, ease of installation. You have an added benefit in that you actually have a resistance to vibration and shock. Remember, this is a copper-based alloy. Typically, the fatigue resistance of a copper-based alloy is going to be better than an iron-based alloy. Again, this is proven time after time, and there's tons of data that proves this, as well as data that we have in-house showing that it has a better fatigue resistance compared to stainless steel and other iron-based alloys. And of course, there are other added benefits, oxygen being one of them, in that if you do have oxygen systems, the clean bore resiliency of tungum is actually used, as well as the safety aspect. It is a non-sparking alloy compared to stainless steels, and therefore you have that added benefit. The cost, this has always been asked, of course, and I always compare tungum to 316 as a baseline. And the reason for this is that 316 is going to be your typical baseline alloy. Some companies actually use a 304 stainless steel, but 316 is pretty much the industry standard. And yes, it is a lower cost alloy, but not by much when you start looking at the lifetime cost compared to tungum. Perfect example is 316 taken as a baseline. Tungum is going to be roughly 50% higher in cost. Again, not a big leap compared to some of the other alloys, the super duplexes, the 6 mollies, and of course all the other alloys that are out there, which are much higher in cost. With respect to 2507 and 6 moly, the added benefit actually is not not significant enough to merit the cost, because even with these two alloys, although you do get an increase in corrosion resistance, the increase only lasts you say anywhere between 8 to 12 years before a crevice corrosion failure. And this is what we've been told in the industry, is that 2507 and super duplex alloys typically fail with respect to crevice and not pitting. So although they have a higher pitting resistance compared to 316 and 317, the crevice corrosion, you still will see a failure. And if you're building for a 30-year asset, ultimately you're going to have to replace tubing at least once or twice before the end of the lifetime of that vessel. The other difference in cost is the fittings. Again, if you're using a standard fitting 316 compared to some of the other alloys, the price is significant. Not to mention the fact that the alloys, the fittings in the other alloys, the super duplexes and the 6 mollies, are typically not on the shelf, which means you have a higher lead time, you have higher costs involved, and ultimately a driving cost as well as the build prices and cost higher. This is a lifetime cost compared to 316, 317, as well as a 316 coated material, as well as 2507 super duplex material and 6 molybdenum. As you can see, and this is taking just a very quick snapshot of an overall build, one size, assuming one fitting for every 20 foot in length, just to keep things simple. If you look at the cost associated and having to change material, we assume anywhere between 3 and 4 years with respect to 316, and roughly twice with respect to super duplex and 6 moly because of the time to failure, and 0 failures in tungum. Looking at the overall 30-year lifetime cycle cost, tungum is more advantageous compared to any of the other alloys, because you never have to change the material compared to the other alloys that we're discussing. Typical applications: hydraulics, utilities, non-process instrumentation lines, again, oil and gas, military, as well as maritime type applications, winches, cranes, anything hydraulically driven or pneumatically driven for that matter. Specifications and approval: we do have ABS full type approval, NORSOC M650. Currently we use the ASME B31.3 calculations, because those are the ones that have been latest update with respect to calculations and pressure allowable stresses, as well as ASTM B706 US specifications, British standard specifications, and of course some of the defense standards that you see below. So this is a material with a very long pedigree, a very long history, a lot of information, a lot of application, and ultimately a lot of specification and acceptance within the marine industry. And that's pretty much the presentation. I know I'm about 4 minutes shy of my time, but nonetheless, perfect time for questions and answers.
Yes, Ruben, it's a perfect time for us to give you some questions, because we have a few. So, if
Good.
you're ready,
Yes.
which ships currently have Tungum installed?
With respect to oil and gas platforms, To name a few off the top of my head, BP has it installed on Thunder Horse,
Okay.
Mad Dog 2. With respect to Hess, Stampede has Tungum installed. There are a various number of maritime vessels that perform various functions, specifically dive support vessels, whose names of the boats escape me, but ultimately they are run by individual companies that provide underwater dive support for various applications, both military and industrial.
Okay.
With respect to cruise ships, with respect to yachts, um, smaller yachts use Tungum, whose names escape me. And as far as cruise ships, this is one of the industries, and this is one of the reasons why I'm performing this presentation to this group very specifically. This is where we need more acceptance in with Tungum for more use. I do have a full list of vessels, and if you'd like, I can supply that to you. Or, of course, I can be contacted from those who want
Yeah.
further information.
Yeah.
Now, what is your global network and delivery times?
So I have 10 global distributors in all parts of the world except for Africa and Brazil. Um, we, each one of those distributors is actually listed on our website with respect to the region of the world. Lead time would depend on, of course, what part of the world we're talking about and which distributor. Most distributors carry a pretty heavy stock of Tungum in various sizes, but they may not have all the sizes and all the stock necessary. So all material will come from the UK. Lead time from us to, let's just say, the United States of America, typical ship time is anywhere between 3 and 4 weeks from port to port. So that would be 3 and 4 weeks to North South America. Anywhere within Europe, maybe a week. Of course, the UK is a couple of days. Middle East, we can probably service within a couple of weeks, maybe 2 to 3 weeks time via ship. So the lead times are very short. Now, if I have to supply material from starting stock to the finished product, I have two options. The first option is to melt from scratch. In other words, melt an ingot and reduce it down into a tube. That could take anywhere between 16 and 18 weeks, depending on the size. That is going to be from start to finish delivery. In most cases, I have actually starting stock hollows at the mill, which actually reduce the time to melt and form hollows. So therefore, I cut that down from anywhere 16 to 18 weeks down to 8 to 10 weeks. So the typical order, if I have to produce actual tube that is not in stock, 8 to 10 weeks is going to be your typical lead time.
Okay.
Okay, thanks for that.
Okay. Could you please explain, can tungum alloy pipes be used in an acid alkaline environment in the exhaust gas cleaning system scrubbers?
So it can be used. It's going to depend very specifically on the fuel being burned. But with respect to sulfur application and sulfur dioxide and some of the other gases, and depending on the scrubber media, um, you're going to have to look at the corrosion resistance of Tungum, which I have a lot of that data in very specific media. And what you need to understand is the acid concentration to be expected, as well as the temperature. With those two data points, I can tell you the expected corrosion resistance of Tungum. And of course, we can choose whether or not it's adequate for the application or not. But those two things are very important: the acid media concentration and the temperature. Those two things will tell you everything.
Okay.
All right.
Could you please tell, like a simple question, uh, where do I purchase tungum for my project, and what are the lead times? Sorry.
So you can purchase Tungum direct from Tungum from T2 Alloys if there is not a distributor in that very specific region. What I would suggest is hypothetical. If somebody's calling me from Norway, I have a Norwegian distributor. I would pass along the inquiry to the Norwegian distributor, and we would check their stock to see how quick the lead times would be. Um, the process could start with us directly and understanding where the material is to be delivered. And from there, we can give you very specific lead times as well as who to contact for purchase of the material. We T2 alloys can be the point of contact to filter that to the various distribution around the world.
Okay, perfect. Ruben, thanks a lot for the Q&A session. Thanks a lot
Oh, thank you
for
guys.
the presentation. Ladies and gentlemen, that was T2 Alloys Limited and Ruben Muro. If you have any additional questions that wasn't raised right now, just send it to us. We will deliver those directly for Ruben. Right?
And good job,
Definitely
guys. I will
right.
say you guys have done a great job. I actually signed on earlier yesterday and today, and some of the presentations have been amazing. Good job putting this together. Thank you.
Sincere
Great.
thanks to
We're
you.
happy that you liked it.
Yeah,
Thank you.
thank you. So, okay, Ruben, then it was very nice to have you here on behalf of T2 Alloys, and let's be in touch. Stay with us.
Thank you. Cheers.